right? So, so this is our M, right? This is our gradient. Remember that M, what is happening here? All right, close and open. Right. So M is our gradient, right? And we want to calculate the acceleration due to gravity, which is G, right? Just say gravity for G, very easy. G, gravity, right? For now, right? You will learn a lot more about this, right? And it's not hard, very easy. Gravity is G, right? And we want to calculate this. It is approximately in a textbook. It is approximately 9.8, right? Approximately it is 9.8, right? This calculation needs to go. I don't know how that got there. Um, so we'll go ahead and calculate it now, right? We'll go ahead and calculate it now with our new gradient of 5.17.
Sir, is the
5
answer 7.86?
7.86 for the 5.17. That's what you got.
Yes, sir.
Uh, Let me just double check it. I haven't done this as yet, right? Times 4. Yeah, about 7.6, right? Which is low, right? So let's just go through it. So we have G equal 4 pi squared over 5.17, right? Um, Pi squared, if you times pi by pi, you're going to get approximately 9. Let me find the exact value. 9.86. You're going to get about 9.86 times 4 over 5.17, right? And if we times 4 times 9.86, we will get 39.4,
13.3.
right? Thank you. 39.4, and we divide this by 5.14. How much do we get?
9.8, 7.86.
7.86. Right. So if we compare 9.8, this is the actual value that is in your textbook of the acceleration due to gravity, the theoretical value, and this is our value that we just calculated, 7.8. We see where it is close enough, right? Very close enough. All right. Um, are we understanding this so far?
Sir,
Yes,
can
sir.
you write again?
Go over it again. All right, no problem. No problem. So we have our formula. This was given by Mr. Treasurer for you to calculate your acceleration due to gravity. Gravity, G, right? We'll learn more about this as we go further down. I probably the next class you will learn, you get a much better idea. But for now, we want to just get the calculation out of the way, right? And we have our M. Remember our M, which is our gradient from the last calculation. We have our G, which is our gravity. We want to find this guy right here. So we say 4 pi squared, right? Same thing over our M. We went ahead and we did our calculation. This calculation is wrong. I don't know who did this. Who did this? All right, this is wrong. Right, rubbish. This is our calculation, right? So G gravity is equal to 4 pi squared. We find pi squared. Pi squared is about 9.8. If we times pi by pi, we get about 9.8, right? And then we times that by 4, right? We times that by 4, and we have some persons who are coming in. All right, so we times that by 4, and we get about 39.44, about that, 39.44, and then we divide this by 5.17, which is our gradient. M is our gradient, and we get about 7.8. No, our textbook says the acceleration due to gravity is 9.8 and this is 7.8. So we are a little off, but it's close enough, right? In your activity, when we calculate acceleration due to gravity, it will be much closer. So are we getting that? Yes, sir. No, sir.
Yes, sir.
Yes, sir.
All right. Listen for any questions. All right. All right. So we for those who are already
Excuse me, sir. I have a question in the presentation that you just ended. You kept saying 5.17 and 5.14. Which is it?
5.17, right? Remember we calculated it. Keep. Remember we calculated it. Around here we calculated 5.17 for our gradient, right? Where is it? Yeah, it should be around here because we had an error here. It should be 0.75. So I need to go back to 0.75, and this was, I don't quite remember. I think it was 0.14. Yeah, 0.14, and then this was 5.17. Right?
Okay. Thank you.
All right, no problem. All right, so let me bring up the activity quickly. It's very tricky because we have 10 minutes left. We have 10 minutes left, and I guess we'll have to move over to the next class again. Right? Give me a second.
Sure, you go put activity in like Google Classroom.
It is already there. You got it from last week, Wednesday. You had the activity from last week, Wednesday. Remember? And I said it will be due today, on Monday. Right?
Yes, sir. Yes, sir.
Okay, thank you. I'm trying to bring it up quickly. Just to go through it. Right? All right, so are we seeing this? This is our activity. Are we seeing this?
Yes, sir.
Yes, sir.
Right, so we got these. It's not hard. We're supposed to calculate the time for one oscillation. Why is this not coming up? No. Calculate time for one oscillation. So we know how to do that. We went through that in class. Remember, we divide time. All right, this is not this is not gonna work. All right, we divide. No, that's not gonna work either. All right, no problem. We divide time by the number of oscillations, and then we find the squared. We're supposed to complete the table by filling in the values of period and period squared. Very easy. We must plot a graph of period squared versus length. So period squared would be in our y-axis and length would be in our x-axis. Just as in the lecture, right? Just as in the presentation a while ago. We find the gradient. We just did that, right? We determine the acceleration due to gravity, and then finding the period of oscillation if the length of the pendulum is 80 centimeters. We can go through that. Well, let me bring up a sample of this section here. And these two multiple choice questions are very easy, right? Very easy questions straight from the CSEC past papers, right? So the activity that I gave you, you were only supposed to plot the graph, right? I wanted to see a graph up to this point. So we will now try and calculate, since we have gone through it in class, we will now calculate the acceleration due to gravity. We will find the gradient, the acceleration due to gravity, and find the period of oscillation if the length of the pendulum is 80 centimeters, right? So Last week for Wednesday, I told you to just do to plot the graph, right? Some persons went ahead and they completed the gradient and the acceleration due to gravity and finding the period of oscillation. So they don't really have any more work to do for now, right? So we're at this point where we need to find this. So we'll go over now. I plotted a graph, right? And I'll just show you my graph, right? Are we getting that so far?
Yes,
Yes,
sir.
sir.
Right. So up to this point, you should have your graph. That's what I was expecting this morning, or this this is what I'm expecting tonight. Right. I'm expecting to see some graph. I'll mark them, and I will give them back to you, and then you'll go ahead and find a gradient, determine the acceleration due to gravity, and find the period of oscillation if the length is 80. We'll do that, right? Let me just go over now to the presentation, the other presentation, which shows the graph. We have not much time. Don't have a lot of time left. Mm, okay. Right, this one here. Give me 1 second. So I'll share my screen. Come on. All right, beautiful. All right, so let me know if you're no wrong presentation. Close. All right, let me know if you're seeing this. Are you seeing this?
Yes, sir.
Yes, sir.
Yes,
All right.
sir.
So this is our same activity, right? We were asked to fill out this table, right? I won't give you the answers, but it's very easy. You fill out these tables here. And this is just our important values, our length and our period squared, just as we did in the lecture. Now, for the graph, oh my God. Right. Sorry about that, Miss Tomlinson. All right, so for the graph, remember what we said. We want to find a value, a random value between the first two values. So we choose this value right here. When we're plotting the graph, let's look on the scale first, right? We have our values from 0, 0.35 to 1. This is our range of values. So we know that our values will start at say 0, thereabout, and it will end at 1. That's our range of values. And we have our period squared. Our period squared values go from about 0 to about 4.5 or 4.25, thereabout. So
Sir,
go ahead.
we go after your graph leaf.
Yeah, you're going to need graph leaf. All right. So this I'll make this due. I'll make you're supposed to plot the graph tonight. I need to see the graph tonight, and then for the gradient and the rest of the calculations, that will be due on Friday. So we'll go through something quickly. Question?
Sir, I already sent my graph to you
Okay, thank you so much. This is for those
on
who
Google
don't,
Classroom.
right. For those who haven't sent their graph as yet, I see your graph. If you send it, I will see it. But for those who haven't sent their graph, it is due tonight. Just the graph alone at 11:59. And then the calculations, this will be due on Friday because we went through it today, right? All right.
No problem.
Okay,
All right.
sir.
So we start at 0. Remember what is happening here, right? We start at 0 and we go up to 1. But what is happening here? Remember this? Remember this? We cut the graph right here, right? We cut this graph right here so we can get a better range of values.
Yes,
Because
sir.
because if we didn't cut the graph, it wouldn't, you will find out that it won't, if you start at 0.1, 0.2, 0.3, 0.4, it will stop about here, right? It will stop about here. And then your graph is supposed to take up at least 75% of the axis, right? So we cut the graph and then we spread out our values, right? We just want to cover that. And of course, for your y-axis, we have from 0 to about 4. This is, so we have 4 spaces in between each. So 1, 2, 3, 4, 1, 1, 2, 3, 4, 2, 1, 2, 3, 4. This comes with practice. So the more we practice doing this, the better we will eventually get. All right. So that's for the scale. Now for the actual points, remember to match your values. So we have 0.35 to 1.5. 0.35 is about here for your first value. 0.35 is about here. And then we match that to 1.5. In the middle of 1, we have 2. So remember, it's more like an estimation, right? This is our first point. Let me just go to the second point. The second point is 0.5 and 2.25, right? 0.5 and 2.25. So 0.5 here on the x-axis. Remember that length is on the x-axis. 0.05, and we match this up, right, to what?
Sir?
Exactly 2.25. Give me a second.
Sir.
Yeah, free soon.
I'm freezing.
Excuse me, sir.
Go ahead. Go ahead.
We're not. We didn't hear the last thing you said.
Right. So
You
you're
were
hearing me now?
breaking up. We didn't hear the last thing.
Are you
Yeah.
hearing? All right. So we have 0.5 here on our x-axis. This is actually your this is your activity, right? I'm just helping you as best as I can in this time, right? I'm not leaving you in the dark. So this is 0.5 and this is 2.25, right? We have somebody coming in here. 0.5 and this is 2.25. So 0.5 on the x-axis, we will match that up. Remember that length is down here. We have length down here and we have period squared over here. So we match this up to the 0.25. So in the middle of 2
Sir,
and 3, go ahead.
we have other class now, sir.
Yes, 9:40. Right, that is correct. So I wanted just try and finish the graph tonight, and then tomorrow we'll move on to a new topic, right? So all the best, guys. My time is up. All right. All the best.
Okay.